This is the COVID test.do file that I posted on Blackboard. The first thing Stata does is you want to type set more off. These are just some settings you put at the top of every file to configure Stata. Clear the matrix, clear the data, so whatever data was in there, whatever matrix was in there, remove that so we could put new data into the system. Set more off if there's a lot of output. Stata will prompt you, say, do you want to show more output? And you keep having to type yes, more output, yes, more output. So set more off just says we're going to show you all of the output. We'll show you all of the analysis and everything that you use. So we're going to install some software on diagnostic tests, diagt. It's an add-on for Stata, so use ssc install. That's going to tell Stata to go online and find the add-on and to install it. Capture, that just means if there's an error message for whatever reason, ignore it. So, for example, I already have diagt installed. I already have the diagnostic test add-on installed. So it might give me an error message, and if I type capture, then it's just going to sort of ignore that. But this should install it if you don't yet have it installed. Use, you could see that I'm typing the address of the data here, that COVID tests.dta, that's saved online, and COVID test.dta, that's the Stata data set that I'll use to evaluate diagnostic tests. So that's on the course website. So highlight all of that and press do, that play button. And now in the window here, it says use toro.csudh.edu. So-and-so has the name of the course and the section and the year, and then COVID tests. So it opens the COVID test data. Remember the tabs on the right. So there's the folder is the project manager. You can see I put some of my projects here. The clock, that's the history button. So that shows things that gave me error messages are in red. You get error messages all the time. It doesn't matter, no harm done. But it does put them in red, so you know that it would give you an error if you tried to do it because there was a typo or for whatever reason. And the list of variables here shows the different things in the data set. Here we just have 2, COVID and test. I'm going to do this in a little more detail here. So tab, COVID. Okay, so how many people in the data were there? There were 500 people in the study. And then remember that 1 is always yes and 0 is always no. So COVID equal to 1, that means like yes, they have COVID. And then COVID equals to 0, that means no, they don't have COVID. So 263 people where COVID equals 0 did not have COVID. 237 people, COVID equals 1, yes, they had COVID. Now, if you do it as a percent of the total people, a percent of the 500 people in the study, 52.6% of them did not have COVID. COVID was equal to 0. And 47.4% had COVID. COVID was equal to 1. Tab test. So this is whether or not the COVID test was positive or negative, whether or not the test said you had COVID. And you can see they're a little different here, right? So because you could have COVID and the test says you don't have COVID, and then you could be healthy, and the test says that you do have COVID. So the tests are never entirely accurate. I can't think of a diagnostic test in the world that's sort of 100% accurate, that whatever the test says, it's what you have. Right? So a common misconception is that the COVID test says you have COVID, it means you have COVID. No, it means there's some chance you have COVID. And if the COVID test says that you do not have COVID and that you're healthy, it doesn't mean you're healthy. It doesn't mean you don't have COVID. It means there's some probability that you don't have COVID. It means there's some percent chance, some probability that you're healthy. So the test gives you some result, and it says whether or not the test thinks you have COVID, but the test is never accurate. So that's the whole point of evaluating the test for this lecture, is see how accurate the test is and have some measures of, well, okay, if the test said you were sick, were you really sick? And then if the test said you were healthy, were you really healthy? And if you talk to people who are working in the field or working at community health centers or out there working in hospitals discussing COVID test results and in the pandemic and so on, they'll say like, oh, there was a lot of false positives. You know, we were telling a lot of people they have COVID when they were healthy. Or the test was saying a lot of people were sick when they were healthy. Or a lot of false negatives. It's saying a lot of people were healthy when they actually had COVID. And they're both wrong, right? So you don't want to tell a sick person that they're healthy, and you don't want to tell a healthy person that they're sick. So that's called a sensitivity and a specificity are measures of, how accurate is this test. Now if you tab COVID test, both of them. Okay, so how many people did not have COVID? COVID equals 0, and the test result was negative. The test said they did not have COVID, and they did not have COVID. 137. How many people had COVID? And the test said they were positive. The test said they had COVID. 135, where COVID equals 1, they had COVID, and the test was positive. Test equals 1. 500 people in total in the study. 263 total people, COVID equals 0 without COVID. 237 people, COVID equals 1 with COVID. 239 people where the test was equal to 0. The test said they were healthy. And then 261 total people where the test was equal to 1. The test said they were positive. Okay, so this is using the software add-on that we use. So it puts the table here, right? So COVID, abnormal means you have COVID, right? True abnormal diagnosis defined as COVID equals 1. Abnormal meaning that you're not normal, you have COVID. Now if COVID normal, that's COVID equals 0, you're healthy. So normal is healthy, abnormal test result, abnormal COVID is you have COVID. The test is positive, the test thinks you have COVID. The test is negative, the test thinks you do not have COVID. The sensitivity, so that's the probability, PR probability, that the test is positive, that's a plus sign. The COVID test is positive, says you have COVID, conditional on you actually having the disease. So if you have the disease, what's the percent chance that the test says you have the disease? 56.96%, and you can see the confidence interval there. So if you have the disease, then there's only a 56% chance that the COVID test comes out positive. And if you do not have the disease, that's tilde, that squiggly mark disease. Do not have the disease, what's the percent chance that the test is negative? That's the minus sign, 52%. So sensitivity, the probability that the test is positive given that you have the disease, conditional, that's the vertical bar, conditional that you have the disease. Sensitivity, probability that the test is positive given that you're positive for COVID. Specificity, probability that the test is negative given that you do not have the disease, given that you're negative. Now what's useful to the patient is the positive predictive value. So you might want to know, okay, the test came out positive. What's the chance I have COVID? Well, that's 51%. That's the positive predictive value. And then while the test came out negative, what's the percent chance that I'm negative? 57%. Overall, what's the prevalence? How many people in the population had COVID? The probability of the disease is the probability of COVID. Well, that's 47%. So sensitivity, what percent of people with the disease does the test detect? 52%, what percent of the people without the disease does the test say are healthy? That's specificity. If you test positive, what's the chance you have COVID? That's the positive predictive value. That's 51%. If you test negative, what's the percent chance you're negative? That's 57%.